Use the expression room for you, X-ray girl. Okay, then you rewrite this. Room is abbreviated RM, but we use that abbreviation a lot. 4 is the Roman numeral 4. U like you're texting. X for X-ray, and G for gamma ray, girl. And then, this is arranging it from the longest wavelength to the shortest wavelength. The R stands for radio waves. The M stands for microwaves. The I stands for infrared, V for visible light. U stands for ultraviolet. X for X-rays, and G for gamma rays. Now you know if they give you 4 of these to choose from and ask you which one has the longest wavelength and the shortest, all you have to do is write this out, and then you can easily answer the question. You don't have to memorize a chart. Just type a little expression, room for you, X-ray girl, and bam, you got your answer. Now let me show you how handy this will be. So, say you're taking your register and you have a question like this. Which of the following has the longest wavelength? So you've got your 4 choices: ultraviolet, infrared, X-ray, visible light. I can't remember. Take your expression, room for you, X-ray girl. Longest wavelength is over at this end. Higher wavelength, shorter wavelength is over at this end. So of your 4 choices here, infrared would be the answer. Of those 4 choices, this is the one that's the farthest to the left. So this is the one with the longest wavelength. And you got a question right on the register. Yay. So if you go on the skull, sorry. So again, see, now you can see why I can move that out. Okay, so we're going to start going back to the very beginning again. Calculating mass, probably one of the first formulas you ever learned. It was mass equals mA times time. Simple, right? If they give you mA time and ask you what mass, no problem. Multiply them together and you're done. One thing to keep in mind about time is it's always in seconds and not milliseconds. And I'm going to show you an easy way to convert milliseconds over to seconds without using the calculator. You're like, what? How's that possible? Now, the thing about this formula is, if you're given a mass value and exposure time and ask what mA would be necessary, then you got to manipulate the formula, and now this one formula has become 2. If you're given a mass value and an mA and you're asked for what exposure time would be required, it's now multiplied again into 3 formulas. So rather than trying to remember 3 versions of the same formula, do this instead. This T format, the way it works is mass equals mA times time, so when you go from left to right, you multiply. You've got mass divided by mA equals time, which is this version right here. You've got mass divided by time equals mA, which is this version right here. So when you go from top down, you divide, and you go from left to right, you multiply. And there's other formulas along the way, including Ohm's law for Ohm's law, power rating, image magnification, all the magnification factor, all of these have 3 factors. Any formula you encounter that has 3 variables, you can set it up just like this. And then the hardest part is sticking the right number in the right place. But I mean, this is half the battle right here. So here we go. Okay, so straightforward. You're given an mA at a time, multiply them together, you got your mass, right? This is how we're going to use this T format. There's mass equals mA times time. You plug in your numbers, there's your mA, there's your time, multiply them together, and you've got your 10 mass. So it's easy to work with that way. Here's another one. 10 mass equals what mA times 0.1 second. Okay, this time you're given a mass value and a time, and you're being asked to solve for mA. Okay, no reason to call to mind one of the 3 versions of the formula. Just set it up exactly the same way. You've got your mass value here. You've got your exposure time here. So 10 mass divided by 0.1 second gives you 100 mA. So again, just one version of the formula rather than 3. And just one final version, one final example. You need 10 mass. You've selected 100 mA. What exposure time is necessary? Now this one will probably go in your head just like the other 2, but just to give you a little practice using this format. So you've got your 10 mass. You've got your 100 mA, 10 mass divided by 100 is 0.1 seconds. And there you go. How's that? Some of you may remember this way, which is even better. But I'm telling you now, any formula that you encounter, there's quite a few that have 3 variables. You can set them all up just like this, and it works out exactly the same way. And I'm going to show you something in just a second. I look at it this way. When you sit for that registry, you've got to remember so much. If you can make it just a little bit easier, do it. Word problems, everybody's favorite. I know, right? You know, when I took algebra in college, I thought, I'm never going to need this stuff. And then I got into X-ray school. It's like, oh, no. Never say never. Tell Justin Bieber. Okay, so here's my advice to everybody when we're dealing with word problems. First thing you're going to do is you're going to scan a question, and you're going to look for a key phrase. Now that key phrase is going to begin with the word what. Sometimes it begins with the word how. Many of your formulas look very similar, like inverse square law and density maintenance formula. They look really, really similar. Well, if you scan through and find, first of all, this phrase will tell you exactly what it is you're solving for, then that can steer you toward the right formula as opposed to the wrong formula. Highlight that phrase. I have students who take tests with highlighters. Go for it. If your teacher will let you. I mean, I shouldn't say, but they let you. And that will steer you toward the correct formula. Reread the question and search a formula and then solve. But this key phrase right here is always going to lead you toward the right formula as opposed to the one that looks very similar to it. So here's an example. You scan through and there's the word what. What MA setting is required? Okay, you already know what you're solving for before you even read the entire question. Highlight that phrase and then you go back. If the mass is 30 and the time is 0.1 second, what MA setting is required? Bring in our handy little T format here. Okay, so we've got our 30 mass here. Our exposure time of 0.1 seconds. What MA setting? There you go right there, because you're on no variable. So you take your 30 mass divided by 0.1, and you got 300 MA. Gotta make sure I don't hit the wrong button, because there's some other things in there too. Here's another example. You have another word problem. Scan through, look, what exposure time is required. That already tells you what you're solving for, and if it's some of your other formulas, it will steer you toward the right one. There's your handy T format. So, you want 80, if the mass to be obtained is 80, you're using the 400 MA setting. 80 divided by 400, 0.2 seconds. How's that? Okay. The metric system. I know, right? You know, here's the thing. Our SID indicators and our field sizes are all in inches, right? That's for our convenience, because in the U.S. we refuse to go metric. They tried back when I was in elementary school to really push it. I mean, really push it. Never caught on. I guess we're stubborn that way. So everything is displayed in inches just for our convenience, but it's actually in centimeters, millimeters, and so on. I think part of the problem was they were selling gas by the liter. And liter to gallon is not a one-to-one conversion. So if it was $1.50 for a gallon and $1.25 for a liter, people were like, ooh, I'm getting it, and I'm getting ripped off. And that might be part of the reason why the metric system just died away quickly. So you take your measured units of measure, and some of the more common ones that we use are length, the meter, time is a second, volt is electrical potential, the ampere, all of your units of measure of exposure right down here. Those are all units of measure, and there's countless others. These are just the ones that we more commonly encounter. So to convert between metric and English, we use the English system. We know that 1 inch is equal to 2.54 centimeters, right? Let's say that you're asked, look this back. 2.54 goes down here, inches goes here, centimeters go here. So if you're given a question, for example, the SID indicator reads 180 centimeters. How many inches does this equal? No problem. You're just going to take your 180 centimeters, put it here, divide it by 2.54, approximately 70.9 or 71 inches. And there you go. Again, anything that has 3 variables, you plug it in and solve for your So whatever you're being asked to. So the metric system is not quite as intimidating if you have a very easy shortcut in order to use it. Let's try another. The text sets the SID at 48 inches. How many centimeters does this equal? Well, you've got your T format. How many centimeters? That's already known. Here's our conversion factor, 2.54. 48 inches, so 2.54 times 48. They all work out the same way. Left to right is multiply, top down is divide. Approximately 122 centimeters. How's that? A little slow on the button. Okay, now remember when you were learning how to add and subtract in elementary school, and you made a little number line, and you went 2 minus 1 equals, okay, that's how you convert between the metric units as well. So there's more on both sides of this, but starting at the top, kilovolts, stands for 1,000, hecto, 100, deca, 10, and then deci is 1/10, centi is 1/100, milli is 1/1000. And then there's more units on both sides of these, but we pretty much work with milliamps, kilovolts, and so on. So we're going to play around with these units for just a second. Now let me show you an easy way. Now first of all, when you're learning metric, you're learning, okay, there are 100 centimeters in a meter, there are 1,000 millimeters in a meter, and you have to do all this memorization, right? No, you don't. Let me show you how to do that. First of all, as far as memorization goes, there you go. Arrange them along a number line, just like in elementary school when you were learning to add and subtract. Kilo, hecto, deca, your base unit goes here, the volt, the rand, the rad, whatever it happens to be, deci, centi, and milli. Converting is just a matter of moving your decimal point back and forth along this line. So how do you remember the order that they go in? One of my students came up with this.
Kill her dad.
Kill her dad, but don't call mom. You remember that,